Okay, please.
Konnichiwa, my name is Phú and my supervisor is Professor Nagahiro Saito. Today I would like to introduce my thesis. The topic's name is synthesis of nitrogen dot, graphene shortest metal nanoparticle and their catalysis for the oxygen reduction reaction. My presentation will have a 5 chapters. The chapter 1 is general introduction. Chapter 2, chapter 3, and chapter 4 is my 3 topics, and chapter 5 is a dissertation summary. Now I would like to introduce the first chapter, general introduction. As you know, nowadays too many researchers and scientists try to replace the fossil fuel by some sustainable energy like geothermal energy, white power, or biomass. In my thesis, I focus on the proton exchange membrane fuel cell. This is the electrochemical conversion which can generate the electric current by the reaction between the hydrogen and oxygen. And they will show some advantages like high fuel efficiency, instant torque, quick refueling, zero emission, fast operation, and scalable to wide range. In case of the proton exchange membrane, the most important part is the oxygen reduction reaction. And now they depend on the process of the oxygen absorption, follow the dissociative process or associative process. They will show the electron process or 2+ to electron process. In case of the associative process, they can generate the 2+ to electron pathway, and also they can do. Maybe you cannot show the presentation file now. So maybe 香澄先生、今1枚目しか映ってませんか？
ズームがついてる。だからあれ、これで発表者モードの上のところを完全にクリック外した方がいい。
No, it's okay. I will change the monitor. Okay, now 1.2.
すみません、こっち変わってるけど、ズームが変わってる。
Nice. Can move this. Okay, can I? Like in case of the associative process, they can generate a 2 electron plus 2 electron pathway. Besides that, they also introduce some byproducts like hydrogen peroxide. Therefore, in this kind of my research, the most important for the EMFC is the catalyst for the oxygen reduction reaction. And nowadays, the most popular catalyst is the PT on the carbon. They can show the electron pathway. However, they show the not so high durability during the working time. And also, they make the poison by the carbon monoxide or some methanol. Therefore, nowadays, so many researchers, they try to enhance the catalytic performance by tailoring the catalytic using the bimetal catalyst. However, this drug, they show the alloying and they lost their performance during the working. And the other people, they focus on the carbon, which is one of the material very stable, especially in case of nitrogen dot graphene. Several researchers already indicate they can catalyze the reaction follow the 2+ to electron pathway. However, due to the low content of the nitrogen doping, they still show some unwanted product like hydrogen peroxide, and this is not good for the proton exchange membrane. Therefore, facing with some drawback and advantages of the nowadays catalyst, I focus on the graphene, the PTM bimetallic nanoparticle by the nitrogen dot graphene. With the graphene, we'll introduce the active side for the ORR and also protect the metal core. And the second method will partially replace the PT catalyst, and also they can tailor the catalytic performance. To make the metal core and carbon shell structure, nowadays they have some conventional methods like the chemical vapor deposition, the thermal decomposition, and the air plasma spraying. They show some advantages like fast growing rates, controllable thickness, and high purity. However, these conventional methods also show some drawbacks like high temperature and cooling system requirements, specific compound needed, and poor doping efficiency. Therefore, I would like to introduce the new methods to generate the metal carbon core cell, namely the solution plasma. This is the method we will discharge the plasma in the solution using the bipolar burst power supply. And in our lab, we already can generate the graphene using the solution plasma. Also, we already can make the PT-based bimetallic metal and also the composite between the metal and carbon. And based on our result, I have an idea. How about we replace the precursor with one can generate very small amount of the carbon, and we can generate the core cell structure. Therefore, in my research, I would like to use the EMF. This is the early particle solvent with the low rates of the decomposition. And this is the one of my proposed for the solution plasma synthesis of metal nanoparticle. Here in the plasma discharge, the sputtering and the carbonization process will occur, and they can make the metal carbon composite. Because the carbon is not so high solubility in the metal, therefore they can dissociate to the surface of the metal, and then they can form the core cell structure. Based on the solution plasma, I would like to introduce you some advantages compared to the conventional methods. Firstly, the solution plasma indicates a simple setup with the one-step process at the ambient condition of the temperature and pressure with the wave dispersion. Besides that, as I already introduced, we can engineer modify the product. We can change the core by just change and prototype to make the metallic core or bimetallic core. We also can change the cell by change the solution, and then we also can modify the thickness of the side of the core cell product by just change some solution plasma condition. Based on my targets, I would like to introduce my 3 topics. First is I try to demonstrate that the nitrogen dot pure graphene can actually protect the core. Therefore, I use the copper nanoparticle, one of the very poor oxidation resistant. And then I will demonstrate that the Graphene-Coated nanoparticle can can generate the catalysis performance for my product. And finally, I try to enhance my catalysis performance of my sample by using the bimetallic core in my research. Now I would like to introduce my first topic is the solution plasma synthesis of remarkable corrosion resistance of nitrogen dot pure graphene-coated on the copper. And now I would like to introduce my literature review. Nowadays, too many researchers already focus on use the graphene or the heteroatom dot graphene to protect the metal substrate. And this is the one paper I already read, and they show that on the breathing graphene, if they show some defects, the breathing graphene can maintain the charge, and that will allow the reaction to continue and destroy the metal phase. However, in case of the nitrogen dot graphene, because of the nitrogen can decrease the conductivity of the system, therefore they can excite with the corrosion. Based on the present of the defects and the high effects, the good effects of the nitrogen dot, I would like to coat in the copper nanoparticle by the several layer of the nitrogen dot pure graphene in my research. Therefore, to make the copper nanoparticle coated by nitrogen dot pure graphene, I use the copper electrode to the copper shot, and I use the DMF for the copper shot. I will process my solution plasma with the condition is 1 microsecond at 100 and 200 kilohertz, and gas distance 0.5 millimeters and time is 60 minutes. And this is the one of my experiments. And during the 1 hour, as you can see, I can collect the colloids of my sample displayed in the EMF. After that, I will try to collect the solid part by the filtration methods using the PTFE membrane with the force 0.1 micrometer. And then I will dry in the oven with the temperature is 100 centigrade in 20 hours, and I can get the sample. And in this result, to modify the thickness of the shell, I will synthesize my sample at two conditions. One is the sample synthesis at 100 kHz, namely CuNFC 100, and the second sample is was synthesized at 200 kHz, namely CuNFC 200. And now I would like to introduce my result and discussion. As you see, this is the TM result, and the CuNFC 100, they show the size around 6.7 nanometer is smaller than the CuNFC 200, and they also show the thick coating around 3 to 5 layers. However, the sample synthesized at the higher frequency, they show the thinner coating. To understand about the crystal structure, I also use the XRD to my sample, and as you see, my sample, they indicate the very sharp bit of the copper, which identifies that my copper core have a high crystallinity. And besides that, the XRD also show the profit of the carbon 002, which indicate the few layer graphene. However, in case of the CuNFC synthesized at the 200 kHz, they show the presence of the oxidized copper, which relates to the uncoated of the copper will be oxidation in the air. This is similar with the commercial one. When I bought from the Sigma address, and after I open and check the XRD, they also show the represent of the copper oxide in the sample. This indicates that with the nanosite, the copper is very easy to be oxidized. For understand about the cell structure, I use the Raman to analyze my sample, and as you see, both of my sample, they show the high intensity of the deep end, which indicate for the defect or the nitrogen dot in my sample. Besides that, my sample also indicate the sharp of the 2D peaks with the I2D per IC is around 0.5, and the full bit at half a moon is under 100, which indicate that my sample is the shell with a few layer carbon. And in my result, I would like to say that in case of my sample, the CuNFC 100 with introduced with the lower frequency will show the more effects and the thicker layer during the high IE band and the low FUSN. And to identify the composition of the core and the shell, I also use the TCA and DTA for my sample. And as you see, the CuNFC 100, they show around 18% of the carbon, which identify that the thick carbon obtained. In case of the CuNFC 200, they show around just 10%. And besides that, after a small loss of the waste, they show the increase of the mass, which indicate the oxidation process will occur during the heating. And for understand about the atomic composition and the bonding state, I also use the XPS to my sample, and as you can see, my whole sample indicate the carbon bit with the long tail for the CN and CO bonding, which identify that my sample was functionalized. And then my sample also indicate the high percentage of the nitrogen is around 3.7 to 3.9, which identify that I already successfully synthesized the nitrogen dot fusion graphene in using the sorption plasma. And as you can see, by calculating the ratio between the nitrogen and carbon and oxygen carbon, I can say that the identical composition also occur on the carbon shell. Besides that, with the high peak of the copper oxide in the CuNFC 200, it also identified that the more oxide content in the sample. For the protectionability of the shell, I also use the immersion test in the nitric acid at 25 centigrade and the sulfuric acid at the 80 centigrade. And as you can see, with the commercial sample and the copper I got from the electrode, and I use the immersion test, they show the poor corrosion resistance. Like after around 10 hours, all the sample already diluted into the acid solution. However, in case of my core shell sample, they show the stable life from 10 to 48 hours, which identify that the low corrosion rate would occur in case of the core cell sample. And the CuNFG1, they indicated the better corrosion resistance in both measurements. To understand what trend in the core cell structure after immersion, I also use the XRD to analyze the solid residue. And as you can see, in case of the CuNFG200, they show the disappear of the copper oxide during the immersion. However, both of the samples still show the very sharp hit of the copper, which identify that the stable of the core structure during the immersion. Based on my result, I would like to inform you that I already successfully synthesized the copper nanoparticle coated by the nitrogen dot layer graphene using the solution plasma method, and I can modify the number of the carbon layer by change the repetition frequency. Besides that, I also confirm with the protection of the carbon cell, they can show the high acid corrosion resistance in case of my sample. Now I would like to introduce you my second topic. This is the ORR catalytic performance on PT coated by NFC synthesis by SP. And this is my literature review because I observed my sample the reaction on the core. Therefore, I searched some paper related to the oxygen reduction reaction on the carbon. And this is the absorption of oxygen onto the carbon surface. Normally, they have two modes of the absorption of the oxygen on the carbon in the Jaeger mode and the Pauling mode. And they already demonstrate that the oxygen atom in the Jaeger mode can further undergo the ORR without the formation of the hydrogen peroxide. Besides that, I already have some interview about what is the effect of the metal, the vinil metal to the graphene, and as you see, they already show some conclusion like in case of chemical absorption, they will confirm by three factors. First is the absorption energy of the oxygen on the catalyst surface. The second is the gaining of charge on the oxygen from the catalyst, and the third is the oxygen bonding elongation for the activation of the oxygen. Besides that, they also confirm the charge transfer, create the donation of the electron to the oxygen to enhance the ORR performance. And to make the PT core and the NFC cell, I just changed the copper electrode by the PT electrode, and this is one of my experiment. And in this result, I will compare my sample, the PT NFC, with the commercial one is a PTC. And this is my research and discussion. As you can see, the GM result of the PTC, they show the no coating with the size around 3.3 nanometer. However, my core cell sample synthesis by the solution plasma, they show a smaller size around 2.3 nanometer with the 2 to 3 layer of the NFC coating. And for understand about the crystallinity of the microcell, I also use XRD and Raman. As you can see, for the commercial one, they show the profit of the metal, which identify the low crystallinity of the PT in the commercial. However, my sample still show very sharp hit, which indicate that the high crystallinity core were achieved. And also, they show the profit of the carbon 002 with the presence of the 2D fit, which identify the few layer of the graphene. Besides that, the commercial sample, they show the high intensity of the event, which identify the defects caused by the PT decomposition. For the atomic composition and the bonding state, I also use the X-ray photoelectron spectroscopy, and as you see, my sample still show the carbon fit with the long tail of the CN and CO. And also, my sample indicate the high percentage of the periodic end, and quaternary end. Besides that, one of thing is very interesting is my sample show the charge transfer effect, which show the bit shift from the 70.7 to the 71.2 at that point. And for the catalytic performance, I use the CV to measure my sample. And as you can see, the core cell sample, they identify the lower hydrogen absorption ability with the negative shift of the ORR peak. which identified us by the coating, the catalytic performance a little bit reduced. However, for understand about how efficiency of my catalyst to the oxygen reduction reaction, I use the linear wave photometry, and as you can see, my sample show the comparable onset potential compared to the PTC. However, they show the slower increase of the current density, which may be related to the hydrophobic of the carbon layer. And finally, however, they still can, after they get the stable, they show the comparable limiting this current. And besides that, when I observe the current at the ring, they show the lower ring current, which identify the lower of the amount of the hydrogen peroxide in case of the when I use the process for the ORR. For more detail, I already calculate the electron transfer number and the hydrogen peroxide yield, and as you can see, the PT and FC show the higher electron transfer number with the lower of the hydrogen peroxide yield, which identified that my sample have a high ORR efficiency via the electron pathway. And for analyze what is the trend in the structure of the my sample before and after the ORR measurement, I also use the X-ray absorption wide structure of my sample and the commercial sample. And as you see at the beginning, the commercial sample, they show the big shift to the higher energy, with like in the iris some like a reference paper, they say the big shift related to the presence of the PT ion. However, after several cycle of the ORR, the peak will shift back to the original position with the increase of the peak at the 11,580, which related to the reduction of the PT ion in the sample. And in case of my crossover sample, they identified that my sample show the similar peak position, and also after ORR, they also show the related of the peak potential also unchanged. Therefore, this identified that the stable slope in case of my sample were achieved. And this is the one of my proposed mechanism for the ORR and proton transfer on the core-cell sample. And in case of the catalyst, in case of core-cell sample, I would like to introduce the process include 4 steps. The first step is a Jaeger absorption onto the NFC shell, and then they will dissociative absorption, followed with the proton coupled electron transfer promoted by the interfacial charge transfer, and finally they can introduce the water and finish the reaction. For like a more higher performance of the my catalyst, I also thinking the durability of the catalyst also very important. Therefore, I already observed the durability test result of the commercial PTC and the PT and FC. And as you can, and I will use the immersion test in the acid condition with the applied potential and without apply of the potential. And as you can see, the result show that my core-cell sample show the better corrosion resistance. Summary, I would like to inform you by trend the PT electrode, by trend the metal electrode. I already can make the order twice of the metal purchased by the NFC, and also my sample already identified the synergistic effect to enhance the catalytic performance of the oxygen reduction reaction via the electron pathway. And now I would like to introduce my topic number 3. This is the NFC encapsulated PT based bimetallic nanoparticle synthesis by solution plasma as an efficient ORR catalyst. And this is also one of my literature review. Nowadays, too many people try to tailor the catalytic performance by using the bimetal of the alloy. And this is one of the research about bimetal of the PT and PD, and they already showed us when they change the composition of the PT and PD, they can tailor in the structure. And finally, they can obscure the best catalyst with the PT3, PD1 with the small energy difference, which indicate the favorable absorption and desorption of the oxygen atom on the catalyst surface, and also enhance the catalytic performance. Therefore, in my result, I also follow some literature review, and I use the gold PT silver PT and palladium PT to like try to enhance my catalytic performance. And therefore, in my research, I research in 3 samples. First is the PT NFC, PT AU NFC. Second is PT AZ NFC, and the first is the PT PD NFC. And this is my result and discussion. As you can see, in case of my sample, all of the sample identify the core cell structure with the coating layer is around 2 to 4 layers, with the size ranging from 2.6 to 3.9 nanometers. It's a very small size, a curve I use in the solution plasma. And beside that, I also use the TEM, EDS to analyze my sample. And as you can see, the carbon, they show the same dispersion of the carbon and nitrogen, which identify that the nitrogen already got on the carbon, and also they show the coexistence of the PT with the metal, which identify the alloy also occur in my sample. And beside that, the atomic composition, I also use and identify as the TMEDS. And as you can see, just change the electrode, the other electrode, you can show the different PT composition. And especially the gold, they show the high, the PT AU energy, they show the high percentage of the PT were replaced by the gold. And for the structure, I also use the XRD, and as you can see, at the enlarged view of the 111 lens, the sample show the slight fixed it identify that the effect between the core and the carbon cell. Beside that, they also show the present of the extra piece, which also identify the alloy core would also achieve. For analyze the cell shape, I also use the Raman, and as you see, the core also affects to the defect on the sample. Just change the other metal on the bimetal of the PTM. They also can show the significant trend of the defect. However, all the sample they show the high peak of the 2D with the FWSM is lower than 100, which identify the few layers of the trend was achieved in our sample. And for the catalytic performance, I also use the cyclic voltammetry, and as you see, all of the coated sample, they identify the lower hydrogen absorption desorption ability, and also they show the slip peak. However, the PT, PD, and FC, they show the comparable current density, during they show the highest the hydrogen absorption and desorption ability. For more understand about the efficiency of the oxygen reduction reaction, I also use the linear sweep voltammetry, and as you can see, all the samples show the comparable onset potential. However, they also show the slower increase of the current density compared to the PTC. But finally, all the samples also show the comparable limit in this current. And beside that, when we observe the ring current, they show the coated sample show the lower ring current, which identify the lower amount of the H2O2. For more accuracy, I already calculate the electron transfer number and the hydrogen peroxide used. And as you can see, the PT, PDFC and PTAZFC, they show the high electron transfer number compared to the commercial one in the ORR potential. Besides that, they also show the low percentage of the H2O2. By on the result, I would like to choose the PT, PDFC for the further result due to it show the comparable current density and the high efficiency for the ORR. And this is my result for the durability after 500 cycle of the CV measurement. And this is the LSV. As you can see, the commercial sample, they show the significant trend of the catalytic performance between the initial and the 500 cycle of the PTC. However, my sample, the coated sample, they show the nearly unchanged of the LSV curve, which identified as the durability catalytic performance were achieved. Therefore, I would like to say the core cell sample indicate the better durability during the 500 CV measurement. And for the other methods, I also use the amperometric test with and without the addition of the methanol. And as you can see, my sample, they show the higher durability of the PT, PD, and FC catalyst. And the commercial one, they show the very weak methanol tolerance of the PTC catalyst. based on my result, I would like to confirm that my sample showed a better durability in terms of the Chernobyl-Ampere matrix and the methanol tolerance in the acid solution. For the practical use, I also use a single test in my for analyze my sample. And as you can see, both of the sample they show the comparable activation polarization. However, my core cell sample they indicate the lower gas transfer, transport loss, and with the higher the power density. Besides that, I also measure the electrochemical impedance spectroscopy, and as you can see, my sample they show the lower emit resistance, and the commercial one they show the higher charge transfer resistance. Based on the result, I would like to say the synthesized sample, core cell sample, show the better fuel cell performance. And based on my result, I also would like to inform that by chance the couple of the electrode I can make the bimetallic of the metal with the coating of the fuel layer graphene, and my result already showed that the core cell sample of the carbon coated the bimetallic they show the practical catalysis for the proton chain membrane fuel cell. And this is the chapter 5, the dissertation summary. Now I want to conclude my research in this chapter. Firstly, I would like to confirm one more time that when I just use the plasma, solution plasma, and train the metal or the solvent, I can make the core cell strip of the PP or the other metal coated by the NFC. The second is by the protection of the NFC, they can give the higher durability core cell structure. And then my sample already identified the synergetic effect to enhance the ORR catalyst performance, and also my sample show the efficiency of the catalyst for the proton chain membrane fuel cell. And now I would like to talk about my achievement. After 3 years, I studied in the Nagoya University. I already get 3 publications. One I already joined 1 domestic conference and joined 4 international conference, and I achieved 3 awards. And I also would like to say my thanks to Professor Nagahiro Saito and the Saito Lab member to always support me during 3 years I studied in Nagoya University. And also I would like to thank to JICA. They already give me the chance to come to Japan and study here. Thank you very much for your attention.
はい、どうもありがとうございます。